Hey everyone, it's Mr. Who. This video is designed as an example, okay, for what you guys might want to put together as a video. It's going to be done all in one take, okay, and I'll include instructions with the Screencast-O-Matic kind if you're going to do that, okay. But again, don't worry too much about the editing stuff. Okay. Try to keep it nice and simple, and I'll let you know in the timestamps when each section is, because I'm going to do both categorical and quantitative, okay. So let's go ahead and begin. Hello everyone, my name is Mr. Who, and I'm giving a presentation today on titled At least 150 or more to see, at least 150 or more to see. So let's talk about it. So first of all, I want to talk about the data I was covering and the question I asked. So there are a lot of Pokemon out there, as I'm sure you know, from Pokemon like Pikachu, very cute, and to Charizard, which is a very strong-looking dragon. But of course, the power varies to each individual. What I want to know is how powerful were the first generation of Pokemon actually? So here's the data, and here's how I kind of completed the survey. The individuals I measured were the original Pokemon. There were 151 of them, so I gathered data on all of them. Next is the variable. For each of the individuals, the only thing I measured from them is their base stat total, or BST, which is kind of a measure of overall power. And this is a quantitative type of data. So what I'm looking for is to kind of compare strong Pokemon and weak Pokemon and see how many Pokemon are actually strong or weak in the first generation. That's the first game. Here's my first display. It's a frequency table. I needed to make one of these in order to make a histogram down the road. And you can see my bins on the left. Okay, I've separated it by 50s, and starting with 180, going all the way to 729, 680 to 729. And these are the frequency and relative frequency in my count, my 151 count. Here's display number 2. This is my actual histogram. As you can see, the bars are very close together, tightly knit. They are all uniform. There's labels on both my axes, and I have a title, which is called the BST survey across 151 Pokemon. Of course, that is what my survey is about, right? So now let's go to the interpretations. In my interpretation of my data, I see that in my histogram, there is not really a shape to think about. It is not symmetrical, it is not skewed. I know this because there are two big long bars on the two bins that are not even near the center, so there cannot be a shape there. My variability is my highest bin, which is 730, minus 180, which is my lowest bin, and that will make me have a range variability of 550. Well, I looked at the center, and when I looked at the counts, I found that the middle range, 430 to 479, the middle bin, I suppose, is the center. It contains my center, even though the shape is not skewed or symmetric, which I find very interesting. So my observations, my conclusion is that most commonly Pokemon fall in the 280 to 329 and 480 to 529 BST bin, which means the majority of Pokemon are not too weak and not too strong. Most of them are above or below average, only slightly. Next, I want to talk about what to do different with this survey. I compared all 151 Pokemon, but maybe it would be more clear to compare only Pokemon that cannot evolve, because what I tried to measure with strengths and weaknesses is how they compare to each other in battle. Another way to kind of do that more accurately would be to remove legendary Pokemon. Pokemon like Mewtwo, for example. Those are very powerful and design powerful. Sometimes they are outliers. In this case, I'm talking about Mewtwo. It is the outlier in my data. And that's my presentation on the BST base stat total of Pokemon to measure their strengths and weaknesses. Thank you for listening to my presentation. Have a nice day. All right, so that was about 4 minutes, okay, for the categorical, not categorical, sorry, quantitative presentation. Now, again, when you go back through these data displays, okay, if your data displays are different, that's totally fine. Okay. You don't have to use a frequency table. If you need to show you how to make a frequency table, I can do that. But it should be in the creating charts, editing charts button. Should be able to do that. But you may have to create another processed data rather from your raw data. which is what I had to do. All right, if you have any questions on making the video for quantitative data displays project, please email me. You may stop the video at this point because I've kind of gotten through what I had to present on. Thank you. Okay, if you're watching from this point, you are looking for the categorical data display presentation and how that might differ if you're talking about, versus quantitative versus categorical. So let's go ahead and get started. Hi everyone, it's Mr. Who, and I'm here to present with the presentation title, At Least 150 or More to See. All right, let's talk about what I'm trying to study here. Okay, so in Pokemon games, evolution is a very big part of the core gameplay. Pokemon evolve, and in order to do that, okay, they have to kind of go through some sort of growth, okay, and they're also related, because when you evolve, typically they are related. That's how biology teaches us, right? So what I want to know, what my question is how many Pokemon can evolve in the first generation? But more importantly, more specifically, how many Pokemon are related in the first generation to another Pokemon? So here are my survey details. What I measured or who I asked, the individual, are the original 151 Pokemon, all of them. So I kind of looked at data on all of them to collect my data. The variable is their evolution status, which I can categorize into 3 pieces. Yes, the Pokemon can evolve. No, the Pokemon is fully evolved, or unrelated, as in the Pokemon doesn't evolve into or from another Pokemon. And this is, of course, a categorical data display. So my first data display, I chose to use a bar graph. This will let me show the counts of every Pokemon, the counts of each category that I have. Yes, no, unrelated. And I've kind of put that up to the side since you cannot actually see them here. And that is my bar graph. I do have a title, axes, okay, and my scale is very appropriate here according to the bars I have. For my second data display, I chose a pie chart. So the pie chart is to show me percents compared to the overall. In order to obtain these percents, I have to take the counts, the frequencies, and divide them by the total number. But Google Sheets will do that for me, luckily, and display the percents. This is a good circle graph, okay, to regard that because it has the percents and a key to tell you which section represents what category. And my title, of course, is related to the percent as well. I also combined yes and no into 1% on the side because those Pokemon are related rather than unrelated. I will be using this data to interpret and make observations based on my question. So here are my interpretations from each different display. From the bar graph, I can tell that most Pokemon evolve. That's like 70 of them evolve. But on the other hand, there are not many related Pokemon. Unrelated Pokemon, I'm sorry. The bar for unrelated is much smaller than the other 2. Even though 70 Pokemon can evolve, only 56 are fully evolved, so that would be the no category. Which means that some families must have more than 2 members, so their line has 3 members instead. And from the pie graph, I was able to obtain this data that 60% are unrelated, which is about 1 out of every 6 Pokemon, which means 5 out of 6 are related. And, that means all Pokemon are kind of, related to something else in the game. So what would I do differently about collecting the data? Well, instead of collecting data on whether the Pokemon will evolve just in the first games, there are many Pokemon games. Which include later games, and they introduce new Pokemon that may be related to Pokemon from this game, which can better show relations, which was the entire point, the question I was trying to pose. I could also have talked about the way the Pokemon evolves, because some of them evolve differently in the games, and they don't all evolve by the same method. Some things level up, or some need to use an item. That would have helped me kind of discern a bit better the 2 categories uh, like kind of split the yes category into more categories. I think that would have helped highlight the relationship. Thank you for watching my presentation on categorical displays for Pokemon relations in the first Pokemon games. Thank you for watching and have a great day. Okay, and if you were watching there, that was again about 4 minutes. If you didn't watch the first one, you probably have no idea what I'm talking about. That's totally fine. So when you're doing this, of course, your two graphs can be different. Okay. If you wanted to use a frequency table, you are certainly allowed to do that. Frequency table is kind of one of those data displays that works for pretty much any um, type of data, whether categorical or quantitative. So you can definitely do that. Um, remember to kind of spruce up your PowerPoint with things that clarify what you're talking about. Don't overload your screens with text sometimes, and make sure that when you use your data displays, that it's either a clean display from your sheets or some sort of image with high resolution like mine is. All right, if you have any questions regarding the categorical presentation, the categorical one, or if you have any issues with Screencast-O-Matic or any other recording software, feel free to email me, preferably before Sunday's due date. And I hope you guys have a fantastic rest of your weekend. Bye bye.